Hello students. In this lecture, we are going to discuss about the concept of electric field lines. Electric field lines are also called as electric lines of force. These lines are imaginary lines drawn in the region of electric field to reflect the basic properties of electric field, including their vector nature. We know that electric field is invisible. In order to have a visual perception of electric field, we draw electric field lines, and they are drawn in such a way that they reflect all important properties of electric field, including their vector nature. By definition, an electric field line is an imaginary line drawn in the region of electric field, the tangent at any point to which gives the direction of electric field at that point. Here in this figure, we can see that the four lines are electric field lines. We can see a tangent drawn at one point to the first of the line. Now this tangent represents the direction of electric field at the given point. Certain rules are employed to draw electric field lines in a given region. These rules can also be called as the properties of electric field lines. Now electric field lines have the following properties. Number one, they originate at the positive charge and terminate at the negative charge. Every electric field line must start at a positive charge and end on a negative charge. That means electric field lines cannot start anywhere and end anywhere. That means electric field lines cannot start or end anywhere. They are smooth and continuous lines without breaks, sudden jumps, and sudden changes in direction. That means that the lines have to be smooth. That means there cannot be sudden changes in direction. Means there cannot be pointed edges if a representation is for electric field lines. No two electric field lines ever cross each other. That means that the path of every electric field line is unique. Electric field lines never form closed loops. The magnitude of electric field is associated to the density of electric field lines in a given region. This means that where electric field lines cluster tightly together, electric field magnitude is higher as compared to the region where they are loosely spaced. As we can see here in the figure, there are 2 points P and Q in the region of electric field where electric field lines have been drawn. We can see that the region where point P is taken, the electric field lines are close to each other as compared to the region where point Q has been taken. Thus, the magnitude of electric field at point P will be higher as compared to that at point Q. Keeping in mind all the properties that we have discussed regarding electric field lines, we can draw electric field lines due to certain charge configurations. The simplest charge configuration is an isolated positive charge. Figure 2 represents electric field lines due to a single isolated positive point charge. You can see that the electric field lines are projected radially outwards from the charge. You can see that close to the charge, the density of electric field lines being higher, the magnitude of electric field is higher. At farther points, you can see that electric field lines space by greater distances. So at farther points, the magnitude of electric field is less. The second figure, figure 2, is a representation of electric field lines due to a single isolated negative point charge. The only difference between the representation of electric field lines due to a positive charge is that in case of a negative charge, the electric field lines point radially inwards. This figure, figure 4, represents the modification of electric field lines due to two charges, plus Q and minus Q, kept close to each other. This representation may also be called as an electric dipole. So, this figure represents the pattern of electric field lines around an electric dipole. The next figure, figure 5, represents the electric field lines due to a thin, uniformly charged sheet of charge. We can see that on either sides of the sheet of charge, the electric field lines point outward and extend normally through the surface. So that is a brief discussion about the concepts of electric field lines. Our next lecture will be based on electric flux, an important physical quantity associated with electric lines of force.